I'm not going to talk about YAML. I might say a few things about Kubernetes, but what I really want to talk is about how you should develop your application to be ready to use all those goodies that we've seen today. Okay? I want to talk about microservices. I promise this is the only slide that does this effect, okay? So don't worry. So we are going to talk about software architecture, and especially about microservices. And we see that microservices answer some of the major promises of software architecture. We talk a bit about eventually consistency, because it comes with microservices, and it's not something which is easy to do. We'll talk a bit, because all this day we heard a lot about hosting and containers, so we just mentioned them, and we'll skip those slides probably. And we talk a bit about orchestration and choreography, and then about how we take our application, whether we should do a revolution, which means to start from scratch, or whether we should take our application and move them into the cloud, into microservices using the evolution approach. So a bit about myself. I am Alon. I'm the Chief Architect of Code Value, one of the founders. Microsoft Azure MVP and Regional Director. Code Value is a software house. We are about 200 people doing many different stuff. We also have a product which is a debugger. Now we write a cloud debugger, so our next product will be a cloud debugger, which means that you can open your browser and debug your production code within the browser. And this was the advertisement. So when we talk about good design, is this a good design? So you probably say, I don't know what do you mean about that. So is this a good design? Maybe, maybe not. Is this a good design? Probably not. Too many connections, right? Is this a good design? If we compare the other designs, so this might be a good one, because we don't have too many of them. There are few connections, few dependencies. They're not too big, not too small, and this is what used to be a good software design if we talk about component. And component can be anything: class, files, computers, nodes, pods, whatever, okay? And this is about the software design. And when you design your software, you need to think about two things: about coupling and about cohesion. By cohesion, I mean the degree, the axis of changes. A component should be responsible only for one thing. This is high cohesion. When we talk about coupling, we talk about the dependencies between different components. And again, a component can be a computer, a service, a class, a file, a function, doesn't really matter. But if one component relies on another component, and if the other component changes, then probably our component also needs to be changed. If I need to deploy something, I might need to deploy all the dependencies of this something, right? So this is about coupling. And we want to have a system which has high cohesion and low coupling, because it will enable much better maintenance, much better understanding, development, and so forth. This is the basic of software engineering. This graph used to be the main responsibility of the architects. In the left side, we have the cyan bars are the size of the component, and the blue bar is the number of components. So on the left side, we have the classical monolith, a single component, very huge. On the right side, we have, it's like microservices, right? Lots of them, very small. And the architect should find the middle. Not too many components, not too big. Why? Because on the left side, to maintain a monolith is very hard. Everybody puts their hands into it. Everything is connected, very high coupling, very low cohesion. On the right side, the components themselves, the microservices, are small, high cohesion, low coupling. But the complexity becomes a nightmare. Okay? So we used to find the middle. So if we have, like, we need to add another functionality to our code, we think whether it should go to one of our existing services or whether we want to create a new service. Nowadays, we want to create a new service. This is the microservices days, right? But back then, we think just for this, let's put it in the responsibility of another one, right? But nowadays, we need to support 24/7, and it is a headache. We need to support versioning. We need to deploy to an existing system, running system, okay? An open heart surgery, right? We need to deploy while the system is running. We need to maintain multiple versions. We need to do a rollback. Again, very hard to do. And this is where we find microservices. And this is from Wikipedia. Microservices is a software development approach, small in size, message-enabled, which is the way to do decoupling between components, use text messages like JSON. Bounded by context, each service has its own context, has its own meaning for different names and namespaces. Deploy separately. Independent, I can deploy one service and I won't affect other services in the system. This is why our servers need to be backward compatible, so you will not break the system when you deploy a new service. Our servers also need to be forward compatible. So if somebody asks it to do something that he does not know, it should answer, I don't know how to do it. So the other service may also result, I don't know how to do it, or maybe try to call again, and by using a load balancer or queue, it will find another service, an old version, new version service that knows how to do it. So we can deploy separately and get the functionality eventually, right? And this is again from Wikipedia. We get enhance the cohesion and decrease the coupling, the holy grail of software engineering. So it's a revolution, but as any other revolution, it's come in evolution way. So we started with a single system with many different parts, high coupling. Then we went to the SOA, the service-oriented architecture, which means that we have a little big services, but we have some sort of service bus, ESB, and then we went to the microservices, which is, we have many services, but each of them is very small. Some principles, service should be small, tiny, 100 lines of code. It doesn't have to be exactly 100 lines of code, but it should be small. Usually you can develop a service in one sprint, which means that if you have a problem in a service, you can throw it and write another one from scratch. Sometimes it's easier than to find the bug that you have in the service. Easy to understand, fast to deploy, cheap to re-implement, as I said. Private data ownership, I will talk about it in a few slides, and eventually consistency, again, I will talk about it. And as I said, versioning. Versioning is very important. From day one in your schema, in your service, you need to maintain version number and know how to treat different. So any call comes with a version number, and now you know how to treat this call. Okay, very, very important. So each service has its own private data. We used to have a single database. In day one in a computer science 101, they teach you that global variable is bad. But then you have single database and many store procedure, which is a many global variables. In microservices, each service has its own database, which means that you need to understand the CAPS theorem, the eventually consistency, which is a very problematic manner. Okay? So you need to know where is the truth, which database, which service provides the truth, and which service has a replica of the truth. Okay? And eventually consistency means that eventually things will be okay. It's a very Israeli way, right? Don't worry, it will be okay. But currently it might not be. If you go to a shopping site and you see that there are 30 books that you can buy. How many books are there? I don't know. Maybe now 100 people bought all those books, right? When you order a flight ticket, when do you know that you have the seat? Only when you sit in the plane airborne, this is the only time that you're really sure that the city is for you. This is eventually consistency. If you go the other way, if you buy a movie ticket and you get like 10 minutes to buy the ticket because they lock this line, they prefer consistency over availability. But then they might lose money. Typical microservice implementation means that you have many different services, usually some sort of API gateway that exposes the public API that you want to provide, an identity provider, and some other services in the area. Each of the services has its own database. Each of the services exposes its own schema, its own service API in its own way. So if you have a movie ticket, you have many different movie tickets because different services needs to have different parameters for this specific movie ticket. Think that you do something wrong. If you need to deploy together, then you have coupling between services. If you have a single code base, you have like a base class for your services, this is wrong, because if you now change the base class, you need to deploy all the services. And if you don't deploy them and you will say, okay, I can handle it and I will deploy in the future, then you'll find that you have the bug that you didn't check. So don't have. Copy is something that they teach you not to do. Copy is decoupling, copy of code. Okay, so from the architectural point of view, it's okay to copy code. And I'm not talking about the cross-cutting concern. I don't talk about logging and database and caching. This is okay to do the reuse because I can choose what is the mechanism that I use. I don't enforce other services to use the same mechanism. So it's not a real coupling. But something that is not a foundation, logic code should be inside microservice. If you have two different services or more talking to the same database, this is the old way to do stuff, not the new way. And if you need to announce that you deploy a new service, you do something wrong with versioning. I told you that I will talk a bit about containers because you heard about them all day, but if we talk about hosting, you need to host your code. And we used to host our code in processes, we used to host our code in daemons or Windows Service, and then we found that there is a magical host, the web server. The web server knows how to host HTML pages, so let's go and use it to host also applications. And this used to be our host, right? Apache, IIS, Nginx. But then we said that this does not provide us the decoupling that we want from the platform. Because if I install a specific version of Java, it might interfere with another service. So I need better decoupling. So I went to virtual machine because now I can have totally decoupled. But with this comes a lot of responsibility for the machine, you know, the pets and the cattle. Now I have to deploy the whole system just for a microservice. So then came the container, the Docker container, and then I need the orchestration, and then came Amazon Lambda, Azure Function, and other serverless that tells you you don't need to mind anything, just deploy your function and everything is going to be okay again, the Israeli way, right? So container takes the complexity that we talked about. We have too many services. We need to somehow orchestrate them. We need to have this hosting. We need to understand how to use resources. This is where the orchestrator come in. And this is why we can go to the right side and have many small services, because we have something else that takes the complexity into account, as long as we develop the service in the right way with all the rules that I talked about. So we use the modern platform to deploy our services, and then we can have many more modules. Without that, it's very, very complex. And if we go to Amazon Lambda or Azure Function or any other serverless, then we even can deploy more of them, because there is a runtime that supports the scale and the resource management. Actually, in the public cloud, it's like an endless resource that I can use. Now, when you go to microservices, you also eliminate legacy code. Why? because you don't have dependency between services, so I can move to the new platform, new runtime, new Java version, new .NET version, whatever. I can move from old language to new language in one of the services, and I don't have to deploy or to upgrade any other service. So if, for example, I have to have a change in one of my services, I can take this service to the new platform while I can continue maintain the other services, and I can plan to move them to the new platform later on. Okay? So eventually I eliminate legacy code. Why? Because it's easy. It's a small service. It's a tiny service. But I have to think about it. I have to plan not to have an old code in my system. Now, there are two ways to design my application when we talk about how to do the call chain, or the logical call chain between services. One way is the orchestration way, and another way is the choreographic way. In the orchestration way, I have a controller, I have a manager. So for example, I have a client user interface calling the shipping manager, and I need to do the shipping, so I have some sort of service that does the shipping, and another service that does the issuing and invoices. Okay? So the shipping manager knows to call, whether it calls to web service or put in a queue a message to the shipping engine, and also to the invoice to issue the invoice. In the choreographic way, I just go to the shipping and tell it to do the shipping. Now the shipping issue or publish an event, and the invoice service sit on these events and know that now it needs to issue the invoice. If I deploy a new service, for example, I want to have a tracking service, in the orchestration way, I need to change the shipping manager. I need to have another version of the shipping manager that now knows how to call also the tracking engine and tells it that now it needs also to track this shipping. So I actually need to change two services. It doesn't mean that I need to deploy them together, right? Because I can deploy first the shipping. It can try to call the tracking, find out that the tracking is not, and roll back to version 1, which is okay. And can try again and again until it finds a service that actually does the tracking. Or I can deploy first the tracking, and then the shipping will find it and use the tracking. So it doesn't say that there is coupling, functional coupling between them. You don't need to deploy them together, right? But in the case of the choreography, I can just deploy the tracking. It sits on the same message that now there is a new shipping, and start to do the tracking. So I don't need to change everything, which is almost correct, but sometimes you'll find that you need to change the message itself, because now for the tracking, you need something that wasn't there, and now the message itself needs to have more payload, something additional field in the payload, and you again change probably also the invoice service. So it doesn't say that in this way you won't deploy other versions. Okay? The two ways are okay. In the left side, it's much easier to understand the system, because you go to the shipping manager and you understand what's going on in the system. Understandability is something which is very important. Traceability is something which is very, very important. In the right side, it's a bit more flexible. It's easier to add things to the system, but it's harder to track, monitor, and understand the system. Okay? But both ways are okay. So, you have a monolith today, you want to move to microservices. What do? You see the spaghetti metaphor here? I really like these pictures. So you do it not everything at once, but we want to have a lasagna, small pieces of lasagna at the end, right? So the revolution approach, which looks like the easy one. The easy one is, you know what? Throw everything just right from the beginning. For sure you will have a microservice application. But it's very hard to convince the management to go with the revolution approach, and there are good reasons why. High risk. You say that it's going to, this system that we built now over 10 years of development, now you need to build it, and you say that you are going to do it in a couple of months. Come on, there are so many things there. Even if you use new tools and new approaches. You don't know all your requirements. You need to dig out the requirements from the current system. It's very hard to reach stability in the system. It's a young system, a new young system. You need to run both systems side by side, which is, again, it's costly. Sometimes it's impossible because you do transactions, so which one is the real one, okay? So again, Revolution eventually will give you a new system. The process will be very hard and very expensive and very risky. The Evolution, which is my preferred approach, start from your current solution. Do the analysis. Think about how you will build a system if it's a new system. What is the goal, the vision that you want to get to? And then do a gap analysis, okay? Once you do the gap analysis, find the components which are most stable, or the components that are in good shape, less problem, or maybe they are high cohesion. So it won't be a microservice, it will be a service, but you can reuse it while you build the system. You can migrate code, you can wrap code, okay? Data and consistency. If you have like a single database, now you are going to split the database to different databases. Think about how you do that. Sometimes you decide that there is a new database, but you replicate the information to the old one, so store procedure and old code can continue use the code while you do the migration. So you have a migration process strategy, what new code that use old code that has to be changed, even though you will eventually throw it, but for now, old code will call a new code, okay? So probably the total effort will be bigger, but you will be on the safe side, and you can release while you do the migration. Okay, so you don't have two systems to maintain. You always have a single system that does this migration from monolith to microservices. So you need to have a project plan, you need to do the analysis and risk and proof of concept project if you want to be sure about things. So again, in most cases, I use the evolution approach if I can. I don't do that if the current technology is obsolete. If I use something, Visual Basic 6, I will not, do evolution. If I could do a migration to new .NET application, new .NET code, fine. But I won't take the same code because it's obsolete. If there are too many black boxes, if I don't have the developers that used to develop the code, so again, I don't want to have them in the code. Too many bugs in the code, too high coupling and low cohesion. And there are tools, there are static analysis tools that can tell you the current situation and the technology depth that you have in the code. And evolution is not black and white. You can decide that this one is a component that you can going to reuse, and this one is component that you are going to throw and build. And I can tell you that 4 years ago, maybe even 5 years ago, I did a project for a company that had a single Java-based JSP client that has the JSP code and the business logic code was in the same monolith. And what I did, the first things that I did is handling the state, having the ability to deploy many different monoliths in a way that I can handle the state and not being stateful. Once I did that, I created, again, I thought about what are the microservices that I want to have in the future, and then I used the same application and mimicking different microservices. It wasn't pure microservice because there are connections inside and you write from one microservice and read from another microservice, so it's not the microservice approach, but it let me to start and split this monolith to different applications and different services, and eventually we moved everything to the new, but it took like 2-3 years. But we deploy all the time, and we got new features while we do the migration, and this is something that management can get, because they get, beside having better software engineering, better product, inner product, we also get new features, and we enjoy new technology and new possibilities. So are microservices the solution? Again, it depends. They all start, if you start from scratch, very nice, but if you don't do them right, you can still get to low cohesion and high coupling, so you need to do it right. You need to stick to those rules that we talked about them. But if you do it right, if you have a very good DevOps process, which is very important, and you heard about it all the day, right? If you do versioning, if you stick to small services, if you know your orchestration or choreography or the way that you do the call, if you have a very good monitoring system, because you need to know what's going on there, then microservices might be the answer for many of the problems that you have today, like eliminating legacy code and deploying fast and all the 24/7 requirements that you need today. So yes, but you need to be this much tall. Okay? If you don't know how to do it, if it's the first time that you do it, get some help. Get somebody that already did it and know how to do it and to do it right from the first place. So thank you very much.